now really speaking a bit about concepts. So we will go a bit more deeper into our solutions. It is now intended for materials researchers. I said before, for me, an average materials researcher has also seen maybe already a line of Python code. It's not for Python developers, but there may be some slides also a bit of Python code. But it's now really going a bit through our solutions without now doing a full onboarding. So going in depth on how things are done will be done in the hands-on sessions. And so it's still an overview, but a more technical overview now. And with this, I would love to hand over to Wolfgang.
Okay, so I want to give you a little bit of an overview about SimStack. What you see here is SimStack 1, which has been used in a number of projects that are basically still running, and where we, basically realize that there's kind of, two kinds of people, and I think this may also pertain to you as potential developers of workflows, right? There is one group who knows how to run Python, and they have a gigantic set of tools available, which Tilman has shown you a few slides back, right? In order to realize the workflows, and of course we like our own, but we acknowledge that there's other workflows which may be suitable for other people in different contexts. But then there is a factor of maybe 1 to 100 to people who don't know Python, right? And they would need some sort of graphical user interface in order to exploit the workflows we do. And so we believe that there is a value, to be able to transfer, the workflow tools to basically a non-expert audience, which can use them, right? So as I'm talking about SimStack 2, and this is maybe now a teaser for the onboarding, which is going to happen in 4 weeks, right? We started to investigate like the lessons learned from SimStack 1, and we also investigated a little bit like what other people are doing. And Tilman has already shown you a number of basically Python-based workflows. But one of our experiences is that when you get this to run, you just generate lots and lots and lots of data. And that's the same also, I think, nowadays in the experimental world, where we move towards self-driving labs, which automate experiments, or where we gather lots of data across many data sources, right? And the point is that this data doesn't help us if you cannot look at it, right? So we don't need data. What we need is human accessible data. We need data from which we can draw conclusions, right? And so we found this company, which I totally love, which is called Neptune AI, and you can type it into your browser now, but maybe still listen to me a little bit. And they specialize on only experiment tracking for machine learning. And basically, this is a prototypical case where you have this problem, right? What does it help you if you have a model with like 12 billion parameters? How do you learn something about the training? You need to transfer this data that you have about the training process into something the developer can deal with, right? And this is what they did. And they were, for a while we thought we could use this, but then it's really focused only on machine learning. And secondly, with hindsight, it was a good idea not to use it because they were just swallowed up for an insane amount of money by OpenAI, because apparently, not only we have this problem, but they also have the problem, right? So the idea is that we have an experiment like machine learning training, right? And from that, we need to generate artifacts. That is the word for human readable data. And artifacts are two things. They're graphs and they're tables. This is the stuff which we as scientists work with every day. Next slide, please. Okay, so that motivates now what SimStack 2, right? Replace machine learning with something more general, right? Keep the rest of the idea. And so if you want to think of SimStack 2, then it's an experiment tracker for material science. Next slide, please. Okay, so how does it work? Well, there is a person, maybe you, who can develop Python code, right? And then in order to make this integrate this into an experiment tracker, you need to build a graphical user interface. Button, please. I hope it doesn't do the next slide. Exactly. So there's an automated way to generate UI elements from the Python code, and that means that they become automatically available in the graphical user interface. Button, please. Okay, and this allows now the non-expert to generate a workflow. Button, please. Then this workflow is automatically executed using the Python code that you've written, and it generates two things. One thing that you want to reuse later, this is the big data set, and the second one are the artifacts, right? And the artifacts are then automatically visible again in the graphical user interface, right? So now what does the developer have to do? If I stay on the right-hand side, well, you write your Python function, and then you do in SimStack 2 the same thing that you do in a lot of these other Python-based tools, such as Prefect, such as Covalent, right? You have a simple decorator, you write add node, and that converts your function into a workflow element. Right? And the second thing you have to do in order to persist your results, and because you want to do calculations on many different nodes and architectures, your arguments to the function have to be converted to database models. And the function has to return something which is also a database model. Right? And that's the only things that you have to change to your Python code. Next slide, please. So you have a decorator that transforms your function into workflow, right? And you have database models for those of you who write in Python, which are based on Pydantic, that convert your data into database elements. Next slide, please. Okay, so now let's go to the workflow user, right? So in the graphical user interface, you have a set of these decorated functions, which are shown you on the right-hand side. So you click on one of them. Next. Okay, and then you get go to an automatically generated interface that allows you to input your data, right? And one thing that you can see there, we will have this in one of the next slides, is you can have a data set and there's an upload button, and so you can upload and download Excel data, right? And on the left-hand side, you can basically tell the machine where you want to run it, right? You can run this on distributed resources, and you have specialized resources for certain parts of the job. Next slide. Okay, now while it's running, you can check it, right? These workflows can be nested arbitrarily deep. So what you see here is like a master workflow, which does something on vibrational spectra of molecules, right? And it calls a bunch of sub workflows which do specialized tasks, right? And they're kind of color coded. If it's green, then everything worked, and if it's red, then it didn't. And so that allows you to keep track of what you were doing at the workflow level. Next slide, please. Okay, and then there's like an overview of what your whole system is doing, like which of your clusters are operational, which jobs are running, and so on and so forth. Next slide, please. So when all of this is done, and here is the slide about the Excel sheet, you can generate data sets which you can inspect regarding your data. And what we think is interesting is that you can do this after your main workflow has been run, because in our experience, nothing ever works on the first shot, right? So you often want to ask questions about your data which you didn't anticipate when you were writing the workflow. And so we have actually gone a little bit beyond what Neptune AI has done, because it allows you to post-analyze your data in unforeseen ways when you plan the experiment. And the second thing you get is images, which should look a little bit better than this, which also have a download button and which you can basically put into your paper if you make them a bit nicer than what I've shown here. Next slide, please. So in summary, we focused on a graphical user interface for an artifact tracker that is aiming at non-experts to run workflows which are made by experts. Data is persisted automatically. That means that everything that has been run once will not be run again, right? And you can reuse this data automatically without thinking about it. These workflows are dynamic as opposed to some of the other engines that you've seen before. That means that there can be a logic within the workflow that decides to take completely different paths for every run, depending on what your data is. We have a web-based tool. That means it's completely browser-based. You don't need to install any app or anything, right? And we have a flexible artifact generation. And if you choose to go in this direction, right, then basically the semantic annotation of the models is relatively easy, because we have the database elements which persist the data. And if you semantically annotate these database entries, then you have semantically annotated your models. That, I think, was my overview, and thanks for your attention.